We'll be looking at multivariable calculus limits. Let's start with our first limit. The limit is x and y approach 1, 1 of xy minus 1 over 1 plus xy. We plug in 1 for x and y and get 0 over 1 plus 1, and so the limit is 0. Next limit, we have x and y approaching 1 and negative 1 of x squared y over 1 plus xy squared. Plugging in x equals 1 and y equals negative 1, we have negative 1 over 1 plus 1, which is just negative 1/2. Next, we have the limit as x and y approach 0, 0 of 1 over x plus y. When we plug in 0, we have 1 over 0, which means the limit does not exist. Similarly, for 1 over x squared times y squared, we plug in 0 and get 1 over 0 and say the limit does not exist. Next, we have the limit as x and y approach 0, 0 of x minus y all over square root of x minus square root of y. Factoring out x minus y, we have the square root of x minus square root of y times the square root of x plus square root of y. The square root of x minus square root of y cancel, and I'm left with square root of x plus square root of y. Plugging in 0, I get that our limit is 0. Okay, next we have the limit as x and y approach 2, 1 of x minus y minus 1 over the square root of x minus y minus 1. We factor the top, so basically you want to put parentheses over the x minus y. So you treat this as like a squared minus b squared. So then you take the square root of x minus y minus 1 times square root of x minus y plus 1. The square root of x minus y minus 1 will cancel, and then we can plug in x equals 2, y equals 1 to get our limit as 2. The next one, we have the limit as x and y approach 0, 0 of x over x squared minus y squared. So this one, when you plug in 0, you get 0 over 0. So there's a good chance that the limit does not exist. So we'll consider two different paths. The first path will be along x equals 0. And for that we plug in x equals 0 and then just leave y by itself. So this is just 0 over negative y squared, which is 0. And the other path will be along x equals y squared. So we're just going to plug in y squared in for x. And then we're going to square the y squared over here to get y to the 4th. Factor the y squared from the denominator. The y squareds cancel, plug in 0, and get that our limit is negative 1. So we found in two different paths, two different limits, so we say the limit does not exist. Next one, you have the limit as x and y approach 0 of x squared over x squared plus 1 times y squared plus 1. This one's nice because we can just plug in 0 for x and y and get 0 as our limit. Next one, we have the limit as x and y approach 0 of ln of x squared plus y squared. This one, I'm going to make a polar coordinate substitution. So we know with polar coordinates, x squared plus y squared is r squared, and then the limit will just turn into r approaching 0 from the right. So we have to be specific because when you're talking about r, that's the radius, it cannot approach 0 from left because it doesn't make sense to have a negative radius. And so this is going to be negative infinity, so we say the limit does not exist. Now we have the limit as x and y and z approach 0 of xy plus yz plus xz all over x squared plus y squared plus z squared. So this one, again, you plug it in and get 0 over 0. So you want to try different paths to show that it doesn't exist. So we'll look at both x and y being 0. So the top becomes just 0. The denominator is just z squared. 0 divided by z squared is just 0. And then if you let everything be the same, so if you let y equal x and z equal x, we have 3x squared on the top and 3x squared is over the bottom. Just 3x squared over 3x squared would just give me 1 as my limit. And because the two limits are different, we say the limit does not exist. Finally, we have the limit as x, y, and z approach 0 of xy plus yz squared plus xz squared over x squared plus y squared plus z squared. And because we get 0 over 0 when we plug in 0, we'll see if we can find two different paths to show the limit does not exist. So first path will be along x and y both being 0. So that just turns into 0 over z squared, which is just 0. And now we're going to convert everything into x. So we'll say y is x and z is x. So we have x squared plus x cubed over x squared plus x squared plus x squared, which really this simplifies to x squared plus 2x cubed over 3x squared. And then from here, we can factor out an x squared from the top. The x squared is going to cancel, and if I plug in 0 for x now, this just turns into 1/3 as my limit. And these limits should also be x, by the way, since y and z are both x. So we found two different paths, two different limits, and so we say the limit does not exist.